Well, hello everyone, and welcome to a new video. In this video, we are going to keep talking about C++ introduction, and we are going to talk about looping in C++. We're going to know what is looping, why do we need looping, how many types of looping, the syntax of each one of them, and when to use each one of them. And then at the end, I will show you two examples maybe to demonstrate the concept of looping. Now, what is looping? As simple as it is, whenever you have a single statement or a block of statements, and you want your program to repeatedly execute this block or this single statement, that's basically what we mean by looping. So, as I said, basically looping it's a tool that you have that will allow you to repeatedly execute the same statement or statements for multiple times. You may ask, why would I need that? Well, the idea here, there are a lot of examples and a lot of applications where looping is really important. So I'm just going to tell you something here, and we're going to talk about that later in the future in next videos. Usually looping and selection structures and arrays, they came together and they work together a lot. So we talked about selection structures. Now we're going to talk about looping, and then maybe next video or the videos after that we're going to talk about arrays, and then we're going to see how they all work together. But for now, let's just talk about some applications for looping. I'll give you an example. Let's say you have a database, and in this database you have hundreds or thousands of students, and you want to know if a certain person is a student in that list or that structure. So what are you going to do? You're going to do a research. And you're going to do a search, sorry. And what is searching? Basically, searching is it's a process of checking each record in that data structure, trying to find a match with the student that you're looking for. So again, that's looping. What else? Video games. There's a lot of looping video games, of course. Like when two players are playing against each other, there will be a loop that are going to keep going until one of those players win, and then the loop will be broken. And there's a lot of more applications. In math, we use looping a lot when it comes to computer science, and we'll see some examples about where looping is really helpful. So I'm not going to keep talking about the applications. We'll see them in the future with a lot of examples, but let's just jump into the basic and the basic looping, which is what we call a for loop. Now, what I want you to imagine, what if I have this statement here? Cout C++ is cool. Now, if I want you to show me this message 10 times, well, imagine you don't know what is looping right now, so you're going to copy this, paste it for 10 times. Here's 5, and here's my other 5. This is considered redundant. Repeating the same code multiple times, basically, it's against everything programming is all about. So instead of showing this statement 10 times to be able to get just wait for it to run to show me this message 10 times, I can actually use a for loop to get the job done. So what I'm going to do, I'm going to take them all out. I'm going to keep one of them only. Okay, here's how it works. You're going to come here, start with the keyword for, and then after that, you open a parenthesis and you close it, and then you open a curly brace, and then you close it here. Now, with time, you'll find yourself not using those curly braces that much whenever you have a single statement that you want it to be repeated. But the moment you have multiple statements, you don't have any other choices but using those curly braces. So put that in mind. For beginners, I will always recommend just to use them so you don't have problems. Now, this part here is where the magic is going to happen. You basically need to put 2 colons, not semicolons, colons. That'll be number 1. Number 2, never ever put semicolon here. You see this highlighted area? Do not put a semicolon here. That's very important. Now, in those, we have 3 fields basically. So first field is basically going to be when you type integer, call it x, and assign it to 0, for example. What is this? This is me creating a counter. I call this counter x. It's a type integer, and I initialize it with 0. Then after that, I will have my condition that will determine if I should keep going with the loop or not. So I'm going to type this. X is less than, let's say, 9. Or let's put 10. Oh, sorry. And let's put there x equal x plus 1. Oh, what did I say colon? It's actually semicolon. Okay. Semicolon, take that out. My bad. I haven't done a lot of C++ lately, so sometimes it happens. So this is supposed to be 10, not 1, and let's keep going. Now, so as you can see here, I got 3 fields. This is field number 1, field number 2, and field number 3. It's very important to understand what is going on here. Number 1, at the beginning, you initialize this counter here with 0. And then immediately you go to the condition here. This is my Boolean expression. As long as x is less than 10, then keep going. Then, by the time you get to the end of this block, this statement is going to be executed. So I would just imagine that at this point here, x equal x plus 1 will be executed. And what am I doing here? Basically, as you can see here, this is an assignment operation. And then we got x plus 1, which basically means whatever the value of x, you're going to increase it by 1. So previously was 0. You're going to increase it by 1, so you're going to get 1. And then x is going to be changed from 0 to be 1. And then you go back, and you have 1 here now. 1 is still less than 10. You keep going, you keep going, you keep going, you keep going, you keep going until you get to the point where x equals 9. When you get to x equals 9, this condition is going to be true still, because again, 9 is less than 10. And then you're going to show this message, and after that, when you get to the end of the block of the statement, you will update the value of x by increasing it by 1, so you get 10. So now x is going to equal 10. By the time you go back to the beginning of the for loop, you will have x here equal 10, and because it's equal 10, 10 is not less than 10, that's where you're going to break your loop, and you're going to leave. And that's basically how a for loop works. So again, I'm going to repeat this. First of all, this is a semicolon, not a colon. That was my mistake. And second of all, we have those 3 fields, and you got the counter declaration initialization. You have the counter, the for loop Boolean expression, and then you have the update for the value of x. You need to have the 3 of them. That's extremely important. Let's just going to run it to show you the results. And I'm going to update it, of course, and talk about it a little bit. Here we go. So you can see I got the same exact results, only instead of having this statement typed 10 times, it's just typed 1 time. Okay, now there are some details that we have to pay attention to. Let me just come here and do this. I put it's cool, and I'll put the value x. Show me x. Like, what is the value of x at the end of each for each iteration? That's basically what we call the processing, or the process of executing this line is called iteration. Let me put end line here. It looks like he doesn't like it for some reason. Okay, let's go ahead and run it. And you notice we'll get 0 all the way to 9. 0 all the way to 9. Okay. What if I came here and I say cout x and line? Immediately we get an error. Why am I getting error? Again, this is something I talked about in the last video. It's basically x is defined inside this loop, inside this for loop. So I can only have access to it and process it and use it inside loop here. But the moment you leave the loop, the scope of the variable, the life of the variable x doesn't exist anymore. So you have to put that under consideration whenever you build a for loop. Once you're out of the for loop, you don't have access to your counter here. That'll be number 1. what if I actually need to have access to it? What do I do in that case? Well, here's what you can do. You can take this one away, cut it from here, and you put it here. And now, oh, let me put a semicolon here, of course. And now, if I want to actually show, sorry, X and line, it will actually show you the value of X with no problems, as you can see here. It's going to show me 10 at the bottom. So this is something to understand. Now, this condition here is very important to understand. Since I start counting from 0, that basically means X is going to start from 0 all the way to 9. What if I don't want to 9? I want to get 10. So you put equal. What if I want to start from 1? Well, just assign it to 1. So it's going to go 1, 2, 3, 4 all the way to 10. And you will notice that the last value X here is going to be 11, of course. Okay, what else do we want to talk about? Okay, I can take this one from here, cut it, and I can put it anywhere I want. But again, if you want to get the same exact effect, it has to be the last statement in your code at this point. If I run it, it will give me the same exact results. And here we go. You don't want to put it at the top because basically it's going to update the value here. Anyway, that's not the problem. Also, I can also take this expression instead from here and put it down. Now, why would you want to do that? There's no reason for that. I'm just showing you possibilities and options that you have. So this, whatever I'm doing here, doesn't mean you have to do it. Usually, we put everything inside those parentheses here. But I'm just going to show you that this is also a possibility. If I cut it from here, and I will come at this point here, and here's what I'm going to say, and I want you to pay attention to this. If X is less or equal 10, break. Now, you remember break from switch. What did we say about break? We said break will let you leave the block of the code, of the switch statement. So this break here, whenever you have it, you're basically going to leave this for loop. Now again, just remember, whatever I'm doing here is just for fun. In reality, this is not how it's done. We have to put them all here. It's going to be a lot easier and a lot simpler. But let me just show you how it works. Oops, what did I do wrong? Oh, sorry. I made a mistake here. Let me put this back here. When I had this expression here, let's just put it here. When I had it here, this basically means as long as this expression is true, keep going. X is less than that. So what I need to do, if I want to go ahead and do a break here, I need to actually flip the operation. So as long as not, and this is again something that I said you should avoid doing. But let me just show you that this basically will work just fine. And here we go. And I got 11 included, of course, because I got the if statement here. If I don't want that to happen, I need to copy it and cut it and put it at the top. Anyway, let me just go back to the original case that I have. And here we go. Okay, so this is again the simple for loop. Remember the syntax. You got for, open parentheses, a semicolon between them. Don't put a semicolon here in this area, a curly brace, a close curly brace, and this is how it works. Now, this expression here is not the best choice you want to use. We do have expressions, and we talked about them, the shortcuts. But for now, it's not shortcuts. Yeah, I think it's shortcuts, yeah. Let me just keep this as it is. I want to show you one tool that we have with C++, which is plus operation, increment operation. So let's imagine I have an integer. I will call it y equal 10. If I come here and say plus y, or I say y plus plus, each one of those operations here will increase the value of y by 1. Update the value of y by 1. This is equivalent to y equal y plus 1, and it's also equivalent to y plus equal 1. All of those 3 lines will get the same job done. Same thing here. Let me copy this, put it here. You'll get the same exact results. Now, of course, if I just replace the plus plus with minus minus, you can imagine what's going to happen. The value is going to be basically subtracted by 1. So if I come here and just type y on the screen and line, just remember I initialized y with 10. This is going to increase it by 1, and this is going to be increased by 1, so I'm supposed to see 12 printed here. And here we go. I got the 12. Now the question that I want you to ask yourself, what's the difference between having the plus plus before or after? Well, this is a good question, and I'm going to answer that question right now. What I'm going to do here, let me convert this into a comment. Now, you see this y plus plus. Sorry, just y here. If I put plus plus y, here's what's going to happen. Since the plus plus is before y, y is going to be updated and then is going to be shown on the screen. So if I run it, I will get 11 on the screen because originally it was 10 and then you increase it by 1, so you get 11. Okay, so what if I actually put them behind yy? Well, here's what's going to happen. Since plus plus is behind after yy, the y original value, which is 10, is going to be used for whatever reason it is, basically is to be shown on the screen. After that's going to be updated. So if I run it, let me just run it and show you. As you can see here, I got 10. But if I ask you what is the current value of y, you have to tell me it's 11. So, but you say here it's showing me as 10. Well, here it is again. Let me just go back. It's going to show the original value, and then it's going to update it. And that's why the difference between plus plus or y plus plus. Now, with that being said, we could come here and replace this with x plus plus, and that's basically the syntax that we use usually. So as you can see here, this is my for loop. This is how simple it is, and this is how it works. Now, what are the different types of for loops that we have? Well, as I said, in addition to this, we have a while loop and we have a do while loop. But just before I get to that point, because I see a lot of questions related to this x plus plus, let me just go back here. I'm going to take this out. So I do have x here, y here, and I have x there. What if I have an integer z? And I want you to pay attention to this. Z equal plus plus y. Okay, versus y plus plus. So I want you to think about this, and I'm going to tell you the answer, and I want you to go ahead and try it yourself later on. So as you can see here, I got plus plus y. So what does that mean? Basically means update the value of y, which was 10, is going to be 11, and then after that use it for whatever reason you're trying to use it, which basically assigning it to the z. Now the question is, what if I have y plus plus? Well, since plus plus is behind, so you're going to have to go and use the original value of y, which is 10, and the 10 is going to be assigned to the z, and then after that, y is going to be updated to be 11. I just thought about let you know about that. So let's move on and let's talk about the other while loop. Before that, I keep coming back to this one. This condition here is extremely important because if you don't pay attention to this condition, guess what? You may end up having what we call infinite loop. Infinite loop basically means when your loop is going to keep going forever. And when your loop is going to go forever, basically if this condition never became false, it's true all the time. So what does that mean? For example, if I just come here and type as long as x is greater than negative 1. So at the beginning, x equals 0. 0 is greater than negative 1. And then you increase x by 1, you get 1. 1 is greater than negative 1, and then 2 is greater than negative 2, and you keep going forever. Let me show you what's going to happen, how the compiler is going to act when you do that. And here we go. Do you see the x value? I can wait until my computer crash after a period of time. Basically, it's going to crash whenever x get too big to a point I cannot handle that number anymore. But as you can see here, this is basically what we call infinite loop. Infinite loop is something you should avoid having. So let's just stop it. Now let's go back and put it to be 10. Okay, now let's move on to the next loop structure, which is what we call a while loop. Now, a while loop basically works very, very similar to the for loop. I'm going to do the same thing. Let me just copy this. I'm going to put it here. And instead of x, I'm going to have a counter. That's my variable. Now, you may ask a question, well, what about the other elements? Well, first of all, I have to come here and create the counter outside and initialize it to 0. In this area, you put your condition, which is basically counter is less than 10. And then here at the bottom, you put counter plus plus. So if you think about it, it's really, really very similar to the for loop. You remember when I started playing around with the for loop, when I put the x here, and I put the condition here, and I put the updating for the counter at the bottom? Well, this is basically very similar to it. And this is what we call a while loop. As you can see here, we got, I should get the same results. Repeat it again. Let me just go ahead and show you that. Okay, so here we go. This is the first 10, 0 all the way to 9. And then I got the second for loop 0 to 9. Now, I know that you're asking yourself, well, if they are exactly the same, why do I have 2? Well, there is a reason, and I'm going to talk about that reason once I'm done explaining the third loop. So let's go ahead and talk about the other loop, which is basically what we call the do while loop. Do, and you open a curly brace and you close it, and you come at the bottom here and you top while, and you put the parentheses and you put semicolon here. Now see, this is important. With the for loop, I didn't put a semicolon here. With the while loop, I didn't put a semicolon here. With the do, you have to put a semicolon here. So what do I do here? You come here at the top, you'll say integer. I'll just call it C this time, assign it to 0. And here I will say, as long as C is less than 0, sorry, less than 10, and let me show the same message again. Instead of counter, I'll just put C here this time. And of course, remember, you need to update C++. Now look at that. What I'm going to do, I am going to come here and put a line breaker. So C out, just for you to understand that this is the result of the first loop, this is the result of the second loop, \n. Let me copy this. And I'm going to put it here. Oops, just happened here. Control V. And I'll have another one at the bottom. And let's run it. And here we go. So as you can see here, I got the exact same results for each one of them. Now remember, those examples that I'm using here is just to demonstrate the concept. But in reality, it's a lot more complicated than this. Now, you have the right now to ask the question, why do I have 3 of them? Why do I need to have all of those for loops? I'll tell you something. Do you see this condition here? This expression, the Boolean expression? Basically, with each one of them, we're saying, as long as this expression is true, execute this statement. So in this case, basically, x is going to be less than 10 for 10 times, from 0 all the way to 9. And after that, when you get to 10, that's where it's going to be false. That's where you're going to leave. Same thing here. As long as this condition is true, then you're going to keep going with the while loop here. Whenever this condition becomes false, you'll leave. Same thing here. As long as this condition is true, you keep going. The moment this condition becomes false, that's where you leave. So basically, the 3 of those repeating structures or loops depends on this Boolean expression. Now, when should I use a for loop? When should I use a while loop? When should I use a do while loop? Let's start with the for loop. Usually, we use for loop when you are 100% sure about how many times you want to repeat that structure. For example, if I have 10 students in my class, I want to do something for each one of those students, let's say grade each student, then I know for sure I'm going to repeat the grading process for 10 times. If I want to check for attendance for my 10 students, then I know for sure I'm going to repeat checking the attendance for each student, and the total number of me repeating that process is 10 times. That's basically when I know exactly how many times I'm going through this. The while loop and the do while loop basically works when you are not sure how many times you're going to repeat the structure. Well, in this case, yes, I know that counter is less than 10, so counter is going to be increased by 1, so it's going to go for 10 times. But believe me, you will have a lot of cases where you're not sure how many times you're going to repeat that structure. For example, let's say this is a video game, and the player will be given a chance to play the game. By the time the game is over and you get to the end of it, you'll be asking the user, do you want to play again? The user will say yes. Well, since he said yes, you have to go back and start the process again. And then after that, you ask the user again, do you want to play again? And he said yes. So you can see here, you're going to repeat the structure depending on the mood of that player. He may want to play one time. He may want to play a million times. You don't know exactly how many times that player want to play. Another type of examples. What if you have an input operation? You're asking the user to enter something, a value, and then that user keep making a mistake. So what do you do? Basically, we put a while loop, and then we check the input of that user. If he make a mistake, we're going to tell him you made a mistake, and then you're going to have to go back and repeat the process until that user enter the value correct value. This is what we call the user input validation process. You need to make sure that the user will not make mistakes, because if he makes mistakes in the program crash, believe me, even though it's his mistake, but they're going to blame you because you didn't put the stupidity of that user under consideration when you build your application. So while loops, basically, we use them whenever we are not 100% sure about how many times the process is going to keep going. Okay, that makes sense. How about the do while? Well, do while and while work in a very, very similar way. But if you pay attention to the while and the do while is what we call a pretest loop structure. Pretest basically means test and then perform. Test and then perform. The do while, perform and then test. That's the main difference between them. So again, it depends on the application that you have. You have to ask yourself, should I get the job done and then I test, or should I test and then perform the job? I'll give you an example. For example, if I want to do an oral test for my students, first of all, I have to ask the question for each one of them, and then I can grade it and decide if he's going to pass or the next student is going to come or not. So basically, you get the job done, and then you test for it. A while loop, no. Basically, you test first, and then you perform the operation or the procedure. Now, one last difference between the while loop and the do while loop. With the do while loop, there is with the while loop, there is a possibility that this loop will never execute at all. For example, if I come here and say, as long as counter equal 10, well, what is the value of counter? It's 0, so this condition is false. So the compiler will jump and move here, and just ignore the body of this loop. Now, let's go back and study the same, update the same change here. If I come here and say plus plus, well, here's what's going to happen. You're going to execute this first, and then you're going to test, and since this is going to be false, so you're going to leave it. So with the do while, you know for sure that at least one time this is going to be executed. But with the while loop, there is a possibility that you may never execute any of those lines. And those are basically the three different types of loops. You can see that the video here is a little bit shorter than the selection, because a lot of the details that we use in loop are repeated in the structure, in the selection structure, so I don't have to repeat myself. but you just have to pay attention to the syntax and how do you use them and the difference between them. Now, okay, so in this example, we are going to go back to the question that I answered in the previous video, where we asked the user to enter 3 integer values, and then we show the user a menu of 4 choices, and we basically had our variable declared here, we have the input operations, and then we said that the value should not be equaled. So I did have my if statement here to make sure that the user will enter a right answer. So in this case, if the user decided to make a mistake by entering 2 values to equal exactly the same, well, basically an error message is going to be shown, and then all this else statement is going to be skipped. So basically nothing is going to happen if the user made a mistake. So what I want to do here, I want to update this value, this project. So if the user decided to make a mistake, basically the message is going to be shown, and then the user will have to go back and continue with the process and enter new 3 different values. So here's what I'm going to do. This is the area where the user is going to make a mistake. So what I'm going to do, I'm going to come here at the top and type do, because I want the user to actually perform this operation. Now, what I'm going to do, of course, I'm going to update everything in a sec, so I'll just put a tab here. This is, again, something that I like, and it's recommended to do. Whenever you have a block of code, the code inside that block of code, basically, give it a tab. So when you look at those white spaces, you understand that this block of code is basically for those curly braces. Now, you come here and type while. So let's just talk about the condition. You basically want the user to enter those values if he make a mistake, and the user will make a mistake if he actually enter 2 values that equals the same. So what I'm just going to copy this and put it here. So if the user made a mistake, you're going to go back and ask the user to enter the values again. If he didn't make any mistakes, well, he's just going to continue normal with the process. I'm going to take this color trace away and this one away to simplify it. And just remember, this is the output message for the user. This is the input operation, and this is your checking just to make sure that the user to show the user a message if he made a mistake here. So we will say, what did I say? No equal values. Try again. Try again. So what I'm going to do here, again, this is recommended. Whenever you have a little bit complicated project, I'm going to convert this to insert. Where is it? Here it is. CN. Again. And here we go. I just commented this section. Just want to make sure that this will work perfectly fine, the process of entering those values. So let's just go ahead and run it. And here we go. Enter 3 values. I'm going to make a mistake. 11, 22, 11. Try again. 1, 2, and 2. Try again. 1, 1, 1. Try again. 1, 2, 3, or 4. See? So that's here. You see, this is an example of a do while. I know for sure I need to ask the user to perform this operation at least one time, hoping he's not going to make a mistake. But if he make a mistake, depending on how many times he's going to make that mistake, that while loop is going to go. So you cannot tell me how many times that user is going to make that mistake. And that's, again, as an example of an input validation process. Okay. So with that being said, now we are 100% sure that the user is actually doing good and the values are acceptable, so I don't need to have that else state anymore. And let me just push them back. Even though I know I'm going to push them back again, I'll just keep going with this process. Okay, so here we go. I'll keep the cases as they are. Yep, that is okay. And here we go. Well, basically I need to take this one away since I don't have the else statement away. So this basically will fix it. Now, the user entered those 3 values correctly. And the user was giving 3 options, 4 options. And he has to go 1 or 2 or 3 or 4. And if the user decided to go with the wrong answer, he's going to go with the default case. Now, I don't want to have the compiler to repeat or the project to be repeat itself if he made mistakes. I'm just going to do this. I want to come here at the bottom and ask the user if he want to actually go ahead and do this again. Like, imagine you want to use this application again. So what do we do here? I can come, and this is very, very important. It's going to make it a little bit complicated, but you have to work with me here. I'm going to go and say while. And I'm going to go and type true. What does that mean? Basically means this is an infinite loop, a loop that's going to go forever. Well, I'm okay with that. Let's just put it that way. I'm going to open it here and go all the way to the bottom and close it. So this is my while loop. It's a kind of very long one. Now let's go ahead, since this is a do while inside it. Oh, already everything is shifted. That's okay, except the switch. Let's go give it a shift. Give this a shift. That's actually a tap, not a shift. And here we go. This is the end of the switch, and this is the end of the while. Now, what I'm going to do, I'm going to come here, and I'm going to ask the user a question. Do you want to run the program again? So what I'm going to come at the top here and put an integer. I'm going to call it answer. And answer is going to be set to, let's say, 0. Or, yeah, let's just put 0 here. Okay, so let's go down and do this. I'm going to come here and say cout. Do you want to run the program again? And I'm going to give the user options. 1 for yes. 2 for no. So again, 1 for yes, 2 for no. Well, here's what I'm going to do actually. I'm going to assume anything is no, but I'm just going to show him 2 is no. In case he typed 3 or 4, 3 or 4 or 5 or 6 or whatever he's going to type is basically going to consider as no as well. So since I have my variable declared here, answer, I need to ask the user to enter that answer at the bottom. I'll say cin answer. Now, in this case, what I'm going to say, if answer doesn't equal 1, so any other value, wait a minute, that basically means yes, break, semicolon. So what does that mean? Basically here, I'm asking the user if you want to run the program again. If he typed 1, that basically means this is going to be false, so this is not going to be executed. But if he typed 2 or 3 or 4, that basically means yes, he want to actually execute. So this is going to be true because whatever he entered is not equal 1. So you're going to break and leave that loop. Let's run it and see how is that going to work. Now I'm going to make a mistake at the beginning, 1 and 2. Okay, now let's go ahead and 3, 4, and 8. So you see that I got those 4 options. I'm going to go with, let's say 3. And the summation for those values 3 and 4 is 15. Now here it is. Do you want to continue or you want to run the program again? I will say yet 1. And here we go. Enter 3 values. 1, 2, and 3. Do you want to, what is your choice? I'm going to go with 4. And the result is 0, of course, because 3 divided by 3 is supposed to be 1. What is that? 2 multiplied, sorry, this is 2 divided by 3, and again, we have integer division. Do you want to continue? No. And here we go, exit. So again, this is me having my program to repeat itself until I decided not to go. As you can see, I used while loop here, I used do while loop here. I didn't use for loop because I have no idea how many times the user is going to run the program. If I know that the user should run it 10 times, I will just come here and say, use a for loop. So this is an example, and now I'm going to be moving on to another example. Okay, so here we have another example where we're going to be using looping to get something done. And in this example, I'm going to go with Fibonacci numbers. Now, just do a quick search about Fibonacci so you'll have a better idea. But just to give you a very quick idea about what is Fibonacci numbers, as you can see here, I got a sequence of numbers here, series of numbers. The first two numbers are set to 1. Now the third number is the summation of the two numbers before it, which is basically 1 and 1. So you get 2. And now the fourth number here, is the summation of the two numbers before it. So 1 and 2 will give you 3. Same thing here for the 5. 2 plus 3, 5. And for the 8, 3 plus 5. And how do we get the 13? Because it's 5 plus 8. And how do we get 21? It's basically 8 plus 13. And I can imagine like this is basically very simple and easy to understand. Now, your job is to write a program, or actually that's my job, to write a program that you want to, if for example, if I want to know what would be the value of Fibonacci number, let's say the 10th one or the 11th one or the 100th one. So that's basically what the program is going to be doing. So we need to come here and we'll start with some basics or assumptions. So I'm going to create two integers. The first one I'm going to call it first, and I'm going to set it to 1. And then I'm going to create another one I will call a second, and I will set second to 1 as well. So those are my two first values. Right after that, I will create a variable. I'll call it n, and I'll set it to 0. This is basically the number that I'm trying to find out, like the location of the number in that serial, for example, the 10th number, the 9th number. So I'm going to ask the user to enter that value. So cout, and let's go ahead and type enter an integer number greater than 1. Okay, I'm not going to put input validation here, so I'm just going to have to go cin and type n, and I'm going to assume the user basically will do the job that he's asked to do. Okay, now I need to have a new integer. Well, it's recommended to create all your integers at the tops. So I'm going to create a new integer. I'm going to call it the Fibonacci number. I'll set that to 0. So that's the final value where I'm going to store the value. So for example, if the user decided to enter the value, for example, 1, 2, 3, 4, 5, 6, then Fibonacci basically is going to equal 8, because 8 here is the 6th value in that serial. So okay, so that's number 1. Since I'm going to use before I do that, what I'm going to do, I'm going to have a very simple if statement. And in this if statement, I'm going to check if the user entered a value for n that is less or equal to. That basically means if the user entered 1 or 2, then the Fibonacci value is basically going to equal 1. That's pretty much how simple that is. So as long as the value n is 1 or 2, the Fibonacci value is going to be 1. And I'm done. Now, what if he entered a value that's greater? That's basically where we have to do the looping here. So I'm going to come here and create an integer. I will call it counter, and I will set the counter to equal 2. This is very important. Why am I setting it to 2? Because I already have the first two values. I know what they are. So that's where I'm going to start my counter. Right after that, I will have this while. And as long as this counter is less than n, the value that the user entered, here's what we're going to do. Now, this is very important to pay attention to. First of all, I'm going to start the process of calculating the Fab value. So it's going to be first plus second. Okay? And then after that, I need to update the values for the first and the second. So the one that was second is going to be assigned to the first. So the first value is going to be basically assigned to whatever the second value was. And the second value is going to be assigned to whatever the result of the Fibonacci number is. And then after that, increase the counter by 1. Now, this might look and sound a little bit confusing. Here's what's going to happen. Let's just have some numbers here to understand. Let's imagine the user entered the value n, let's just here, example, n equal 4. So what's going to happen here? 4, here, this is N4. First of all, counter is going to equal 2, and 2 is less than 4, so that's true. Here's what's going to happen here, and I'm going to just do it here. Fibo, which was 0, is going to equal first plus second, which is basically 1 plus 1, and that is going to equal 2. Right? This is basically what we call tracing the execution. And this is something that you need to do every time you have a program that is not working or you're trying to understand a program. Now, what I'm going to do here, I'm going to come to first, and I'm going to set it to second, which is basically equal 1. So that's okay. And then second is going to equal the result of Fibo, which basically is 2. So by the end here, counter is going to equal 3, and then first is going to equal 1, and second is going to equal 2. So if you think about it here, if I go back here, I just moved from this is first and this is second to this is first and this is second, and that's basically what happened here. First, second, it's 1 and 2, and I'm moving on in my process. Now, let's move on. Counter equals 3, so 3 is still less than 4, and now we're going to have to update Fibo. Now, first still equal 1, and second equal 2, so the final result here is going to equal 3. Now we come to the first. What was the value of second? It was 2, and the Fibo basically is going to equal 3 here, because that's basically what's going on here. And then the counter is going to be increased by 1, so it's going to get 4, and that's where I'm going to stop, because after you go here, 4 is not less than 4, and you're going to stop. So the final value of Fibo is going to be 3. Now let's go back. The fourth element is basically 3, and that's how the calculation is done. So let me take those comments away, and let's give this a run. I'm going to try to see if I go with 1. Oh, wait a minute. My bad. I forgot. I have to show Fibo here. And line. Let's run it again. Uh-oh. Of course. Nope. Coconut. Okay. And let's go with 1. I'll get 1. If I go 2, I'll get 1 again. Let's go ahead and enter. So this is 1, this is 2, 3, 4, 5, 6, 7, 8. Let's put 8. Oops, what is this? What is this? Let's go back and run it. And let's put 8 and 21. And as you can see here, 8 is 21. So this will be the end of this video. I hope you didn't find it difficult to understand. And remember...